Hello, in this lecture we will find the area of a circle. In the drawing we have a circle and inside the circle we have a shape. Two angles of this shape are equal to 90 degrees. Angle ADC is a right angle, it equals to 90 degrees, and also angle BCD is a right angle and it equals to 90 degrees. And side AD of this shape equals to 4 units, side DC equals to 6 units, and side BC equals to 8 units, and we want to find out the area of this circle. Okay, first of all I will explain the theorem one-sided angle. Okay, suppose that we have two lines, line A and line B. And this is line B, this is line A, and we have a third line, line C, that intersects those two lines, line A and B, at points M and N. Line C intersects line A at point M, and line C intersects line B at point N. Okay, actually angle alpha and angle beta are defined as interior one-sided angles. I'll write it here. Angles alpha and beta are defined as interior one-sided angles. Okay, in this drawing, angles alpha and beta are defined as one-sided interior angles. Okay, and we have another possibility. if we have two lines, line A and line B, this is line A, and this is line B, and we have third line, line C, that intersects those two lines, line A and line B. Line C intersects line A at point M, and line C intersects line B at point N. Actually, angle alpha and angle beta are defined as exterior one-sided angles. Okay, angles alpha and beta are exterior one-sided angles. Okay, angles alpha and beta are defined as exterior one-sided angles. Why angles alpha and beta are one-sided angles? Because they are both of them on one side of this red line C. They are located on the right side of line C, because of the fact that angle alpha and beta both located in the right side of line C. This is the right side of line C. They are defined as one-sided angles. And also here, angles alpha and beta located on the right side of line C, therefore they are defined as one-sided internal angles. Okay, so actually we have a rule, I will call it rule number 1. Actually, rule number 1 states that if the sum of the angles, that is to say alpha plus beta, equals to 180 degrees, then A is parallel to B. Okay, so I write it down. Again, if the sum of the angles alpha and beta equals to 180 degrees, then line A is parallel to line B. So I write it down. Rule number 1 states that if the sum of angles alpha and beta equals to 180 degrees, okay, if alpha plus beta equals to 180 degrees, and also here if alpha plus beta equals to 180 degrees, then line A is parallel to line B. Okay? So I will read rule number 1 again. Rule number 1 states that if the sum of angles alpha and beta equals to 180 degrees, then line A is parallel to line B. Okay? Here, if alpha plus beta equals to 180 degrees, then we can deduce that line A is parallel to line B. And also here is the same rule. If the sum of alpha plus beta, or if alpha plus beta equals to 180 degrees, then we can deduce that line A is parallel to line B. Okay, so actually we can implement rule number 1 in our circle. We can implement rule number 1 in our circle because in our circle we have two right angles. This angle is a right angle, it equals to 90 degrees, and this angle BCD, is also a right angle that equals to 90 degrees. Actually, those two angles, angle ADC and angle BCD, are one-sided internal angles. And the sum of those two angles, ADC plus BCD, is 90 degrees plus 90 degrees equals to 180 degrees. So according to rule number 1, line segment AD is parallel to line segment BC. Okay? So I will write it down. Angle ADC equals to 90 degrees, is a right angle, plus angle BCD is also equals to 90 degrees. So the sum of those two angles, angle ADC and angle BCD, angle ADC plus angle BCD, the sum of those two angles equal to 180 degrees, because 90 degrees plus 90 degrees is 180 degrees. Okay, the sum of those two angles equals to 180 degrees, and therefore, according to rule number 1, according to rule number 1, line segment AD is parallel to line segment BC. So I will read again the implementation of rule number 1 in our circle. Angle ADC equals to 90 degrees. This angle is 90 degrees. Plus angle BCD also equals to 90 degrees. Angle BCD is also 90 degrees. And the sum of them, 90 degrees plus 90 degrees, is 180 degrees. And therefore, according to rule number 1, line segment AD is parallel to line segment BC. Okay? Again, the sum of those two angles, ADC and BCD, is 180 degrees. So and they are one-sided angles. Angle ADC and angle BCD are one-sided internal angles. So according to rule number 1, line segment AD is parallel to line segment BC. Okay, so those angles ADC and BCD are right angles. So I'll write here that angles ADC and angle BCD are one-sided internal angles. Okay, so angle ADC and angle BCD are one-sided internal angles, and the sum of those two angles, those two one-sided internal angles, equals to 180 degrees. Therefore, according to rule number 1, line segment AD is parallel to line segment BC. Okay. So, in the next step, we will connect together by a straight line points D and B. And we will also connect together by a straight line points A and C. And we will call to the intersection point between line segment AC and line segment DB O. Again, the intersection point between line segments AC and D is defined as O, or point O. Or point O is the intersection point between line segment AC and line segment DB. Okay, and in the next step we'll focus on two triangles. The first triangle is triangle BOC, the green triangle POC, and triangle AOD. Okay, we will focus on those two green triangles. We will actually prove that the angles of those two green triangles are equal to each other. Okay, so I'll write down that in triangle AOD, green triangle AOD, and triangle BOC, actually angle AOD equals to angle BOC angle AOD, this angle is equal to angle BOC because those two angles are vertex angles, and vertex angles are equal to each other. Okay, angle AOD equals to angle BOC because of the fact that those two angles are vertex angles, and we actually have rule number 3, rule number 2, that vertex angles are equal to each other. So actually I will explain what is vertex angles. When two lines are intersecting each other, if we have two lines that are intersecting each other, let's say that that is the intersection point between line A and line B, they create 4 angles. So by the intersection of two lines with each other, four angles are created. This is angle 1, this is angle 2, this is angle 3, and this is angle 4. Okay? When two lines are intersecting each other, they form or they create four angles. 1, 2, 3, 4. And actually, angles 1 and 3 are defined as vertex angles. Angle 1 and angle 3 are defined as vertex angles. And they are equal to each other. That will be rule number 2. That vertex angles are equal to each other. So, actually, I read what I wrote. Angles 1 and 3 are defined as vertex angles, and they are equal to each other according to rule number 2. Actually, angles 2 and 4 are also vertex angles. I'll write it down. Are also defined as vertex angles. And they are also equal to each other. So I'll read what I wrote. Angles 2 and 4 are also vertex angles, and they are also equal to each other. Okay, angles 2 and 4 are vertex angles, and they are also equal to each other. As angles 1 and 3 that equal to each other because they are vertex angles, angles 2 and 4 are also vertex angles, and they are equal to each other. So actually, if we have two lines that intersect each other, two vertex angles are equal to each other. we have in the drawing line A intersects with line B at this point, and actually angles alpha and beta are vertex angles, and according to rule number 2 they are equal to each other. That is to say, alpha equals to beta, and the second type, the second possibility of vertex angles that are equal to each other is so there is the second possibility that alpha and beta are vertex angles. So this was the first possibility of vertex angles that are equal to each other, and this is the second possibility of two vertex angles alpha and beta. According to rule number 2, they are equal to each other because vertex angles are equal to each other. So I will write down rule number 2 that states that vertex angles are equal to each other. Okay? Okay, so rule number 2 states that vertex angles are equal to each other. So we implemented rule number 2 in our circle because in our circle we have two vertex angles, angle AOD and angle BOC are two vertex angles, and according to rule number 2 they are equal to each other. That is to say, AOD equals to BOC. Okay? So I'll write it down. So in these two green triangles, we have first angle, and we have two angles. This angle equals to this angle, so angle AOD equals to angle BOC because they are vertex angles, and according to rule number 2, vertex angles are equal to each other. Okay, angle AOD equals to angle BOC because they are vertex angles, and according to rule number 2, vertex angles are equal to each other. We have angle DAO that equals, in this small green triangle, that equals to angle BCO, to this angle. Okay, so those two angles are equal to each other according to the next rule, rule number 3, that states that alternating angles between parallel lines are equal to each other. First of all, I will write down the equality. Angle DAO equals to angle BCO. Okay, those two angles. According to rule number 3, that states that alternating angles, those two angles are alternating angles between parallel lines, AD is parallel to BC, are equal to each other. Okay, and write it down. So angle DAO equals to angle BCO according to rule number 3, that states that alternating angles between parallel lines are equal to each other. So now I will explain in details what are alternating angles. Okay, actually, if we have two parallel lines, line A is parallel to line B, so from the beginning we know that line A is parallel to line B. And then we have two lines, line A and line B, and we know that line A is parallel to line B. And we have the third line, line C, that intersects those two lines. Line C intersects those two lines A and B, at points M and N. So the red line, line C, intersects those two lines at points M and N. Then actually angles alpha and beta are defined as internal alternating angles, and according to rule number 3, those two angles alpha and beta that are defined as internal alternating angles are equal to each other. Okay? And we have other possibility that exterior alternating angles between parallel lines are also equal to each other. So if we have two lines, line A and line B, and we have the third line, line C, that intersects those two lines at points M and N. Okay, we have two lines A and B that are parallel to each other, and we have line C that intersects lines A and B, let's say at points M and N. Actually, angles alpha and beta, first of all, they are alternating angles. Why angles alpha and beta are alternating angles? The reason is that angles alpha and beta both are on the opposite side of line C. Angle alpha is in this side, for example in the right side of line C, while angle beta is the left side of angle C. So they are in two different sides. They are in two opposite sides of line C. Okay, for that reason they are called alternating angles, and they are external alternating angles because they are, this angle beta is above line A, while this angle alpha is in the bottom of line B. For that reason, they are defined exterior angles, and for the reason that they are in the opposite sides in relation to line C, they are defined as alternating angles. So those angles, alpha and beta, they are alternating exterior angles. Okay, so I'll write it down. So those angles are alternating exterior angles. So actually, if A is parallel to B, then alpha equals to beta. This is rule number 3. If line A is parallel to line B, then alpha equals to beta. Okay, those angles alpha and beta are alternating exterior angles, and if line A is parallel to line B, then alpha equals to beta. Angle alpha equals to angle beta. The same rule is in this, those angles alpha and beta. Those angles are defined as internal alternating angles. Okay, I'll write it down. The same rule applies to those two angles. So if A is parallel to B, line A is parallel to line B, then angle alpha equals to angle beta. Okay, those two angles are internal alternating angles, so interior alternating angles. Okay, those two angles alpha and beta are interior alternating angles, and if line A is parallel to line B, then alpha equals to beta. Okay, so I write down rule number 3 that I have already mentioned. Rule number 3 states that alternating angles it doesn't matter at all if they are interior or exterior. It applies to both of them. So right here, alternating angles between parallel lines are equal to each other. So I will read again rule number 3. Rule number 3 states that alternating angles, doesn't matter at all if they are interior or exterior alternating angles, it applies to both those two types. Alternating angles between parallel lines are equal to each other. So if we know that line A is parallel to line B, then those two alternating internal angles are equal to each other. And also the same rule about exterior alternating angles. If we know that line A is parallel to line B, then those two exterior alternating angles are equal to each other according to rule number 3. Okay, so we actually implemented this rule in our circle because we know that line segment AD is parallel to line segment BC. Okay, so according to rule number 3, alternating angles, angle DAO and angle BCO, are two internal alternating angles. So if we have two lines that are parallel to each other and we have two alternating angles, then those two alternating angles are equal to each other. So angle DAO is equal to angle BCO according to the rule number 3 that states that alternating angles between parallel lines are equal to each other. Okay? And actually also the third angle, angle CBO, and angle ADO are both alternating angles between parallel lines, therefore they are equal to each other according to rule number 3. So we can write down that angle CBO is equal to angle ADO. According to rule number 3 that states that alternating angles between parallel lines are equal to each other. Line segment AD is parallel to line segment BC, and therefore those two alternating angles are equal to each other according to rule number 3. Okay? So actually angle CBO equals to angle ADO because of the fact of rule number 3 that alternating angles between parallel lines are equal to each other. Okay, so we actually succeeded to prove that the green big triangle, all the angles in the big green triangle equal to all the angles in the small green triangle, because we proved that this angle in the big triangle equals to this angle in the small triangle. This angle in the big triangle equals to this angle in the small triangle, and this angle in the big triangle is equal to this angle in the small triangle. So we proved that those two triangles are similar triangles. So according to A is abbreviation for angle. According to angle, those two green triangles are similar to each other. Triangle, the big triangle BOC is similar to the small triangle AOD. Okay, we proved that three angles in this triangle are equal to three angles in this triangle. Therefore, according to the rule of angle, those two green triangles are similar to each other. So triangle BOC is similar to triangle AOD. Okay, and actually, what is the rule in the similar triangles? If we have two similar triangles, so for example, if the big triangle ABC is similar to triangle DEF, that is to say, three angles of this triangle are equal to three angles of this triangle, then the following relationship is true for the sides of those two triangles. AB over DE equals to BC over EF equals to AC over DF. Okay, so the relationship between the sides of those two triangles, of those two similar triangles, are that AB over DE equals to BC over EF equals to AC over DF. Okay, so actually we can implement the rule of similar triangles in our circle, because we proved that those two green triangles are similar to each other. Therefore, we can say that OB over OD equals to OC over OA equals to BC over AD. So the following relationship is true on those two similar triangles, those two green similar triangles. BO over OD equals to OC over OA equals to BC over AD. Okay? But we know it is given us in the question that BC equals to 8 units, while AD equals to 4 units. So we can write BC equals to 8 units and AD equals to 4 units. So, and 8 over 4 is 2. Okay, so we know that OB over OD equals to 2. Okay, OB over OD equals to 2, so actually OB equals to 2 times OD. We multiplied this equality by OD, so OB equals to 2 times OD. And also OC over OA equals to 2. Okay, OC over OA equals to 2, so we can multiply this equality by OA. So we got that OC equals to 2 times OA and OB equals to 2 times OD. So if OB equals to 2 times OD, so actually if OD is A, then OB equals 2 times OD, so OB equals to 2A. And we also know that OC equals to 2 times OA, so if OA is B, then OC equals 2 times OA. OC equals to 2 times OA, so that is to say OC equals to 2B. Okay? Now we will focus. Angle ADC is right angle, so triangle ADC is a right triangle, so we will focus on right triangle ADC. Again, angle ADC is a right angle. Therefore, triangle ADC is a right triangle. So we will implement the Pythagorean theorem in the right triangle ADC. according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AD square plus BC square. Okay, according to the Pythagorean theorem, in the right triangle ADC, AC squared, that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to AD square plus DC square. But we know that AC equals to B plus 2B. B plus 2B is 3B. So AC square is 3B square equals to AD square. AD equals to 4, so AD square is 4 square, that is 16, plus DC square. DC equals to 6, so DC square is 36. So in total we got that 3B square equals to 16 plus 36. 16 plus 36 equals to 52, so I will write it down. So 16 plus 36 is 52. Now we'll take a root from this equality. So we got that root of 3b square is 3b, and we have square root of 52, but 52 equals to 13 times 4, so I write it down in order to simplify the number. So the root of 52 is 4 times 13, and the root of 4 is 2, so I write it down. So we got that 3b equals to 2 times root 13. Now we will divide this equality by 3. So we got that b equals to 2 over 3 times root 13. If b equals to 2 over 3 root 13, then 2 times b equals to 4 over 3 times root 13. So you write it down. Okay, 2 times b equals to 4 over 3 times root 13. Okay, so we found out the values of b and 2b, so can add here that b equals to 2 over 3 times root 13, while 2b equals to 4 over 3 times root 13. In the next step, actually angle BCD is a right angle, it equals to 90 degrees. Therefore, triangle BCD is a right triangle. So we can implement the Pythagorean theorem in the right triangle BCD. So the square of the hypotenuse is dB square, and it equals to the sum of the squares of the perpendiculars, equals to DC square plus BC square. Okay, we implemented the Pythagorean theorem in the right triangle BCD. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, but what is the value of line segment DB? The value of line segment DB is A plus 2A is 3A. So we have 3A squared equals to DC square. This is 6. So DC square is 36. Plus BC square. BC is 8, so BC square, 8 square is 64. In total we got that 3A square equals to 36 plus 64. 36 plus 64 is 100. So I write it down. So we got that 3a squared equals to 100. Now we will take a root of this equality. The root of 100 is 10, so I will write it down. So we got that 3a equals to 10. I will divide this equality by 3. We'll get the value of a. So we actually got the value of a equals to 10 over 3 units. If a equals to 10 over 3 units, then 2 times a will be equal to 20 over 3 units. Okay, so I write it down. Okay, 2 times a equals to 20 over 3 units, and a equals to 10 over 3 units. Now I will add the values to a equals to 10 over 3, while 2 times a equals to 20 over 3 units. Now I will copy this drawing here, because we have too much numbers and variables, so I will put only the numbers in those line segments. AO equals to B, and B equals to 2 over 3 times root 13, while OC equals to 2B, that is to say 4 over 3 times root 13. DO equals to A, and A equals to 10 over 3 units, while OB is 2A, and 2A equals to 20 over 3 units. So actually in this way we calculated all the values of the line segments in this circle. Okay, and in the next step we will extend line segment AC until it touches the circle at point, let's say at point P. So we actually extended line segment AC until it touches the circle at point P, we created new line segment PC or CP, and we want to find out the value of PC or CP. It's the same. In order to find out the value of CP, we actually have a new rule number 4. According to rule number 4, if two chords are intersecting each other, let's say at point O, let's say that this chord is chord AB, and chord AB intersects with chord CD, at point O. The intersection point between chord AB and chord CD is at point O. Then, in this situation, the following equality is true. AO times OB equals to CO times OD. Again, according to rule number 4, if we have two chords, chord AB and chord CD, that are intersecting each other, and the intersection point is at point O, then the following equality is true. AO times OB equals to CO times OD. So I will write down rule number 4. So actually rule number 4 states that if two chords are intersecting each other, if two chords A, B and C, D are intersecting each other at point O, So O is the point of intersection between chord AB and chord CD. Then the following equality is true. that AO times OB equals to CO times OD. So I will read rule number 4 again. Rule number 4 states that if two chords, let's say chord AB and chord CD, are intersecting each other at point O, they intersect in each other at point O, then the following equality is true. Then the point, in the point of intersection, that is to say at point O, we have the following relationship between the line segments that was created because of that intersection. AO times OB equals to CO times OD. Okay, again, AO times OB equals to CO times OD. Okay, so we actually can implement rule number 4 in our circle in order to find out the value of the new line segment CP. And we actually have two chords that are intersecting each other at point O. Chord AP and chord DB are intersecting each other at point O. So I write it down. Chord AP and chord BD or DB are intersecting each other at point O. Point O is the point of intersection. Therefore, according to rule number 4, according to rule number 4, AO times OP equals to DO times OB. Again, AP intersects with DB at point O. Therefore, AO times OP equals to DO times OB according to rule number 4. So I will read again the things that I wrote. Chord AP and chord DB are intersecting each other at point O. Chord AP and chord DB are intersecting each other at point O. Therefore, according to rule number 4, the following equality is true, that AO times OP equals to DO times OB. AP intersects with DB, therefore AO times OP equals to DO times OB. Okay? But AO equals to 2 over 3 times root 13, so I write it down. while OP equals to OC plus CP. OP, line segment OP equals to OC plus CP. So OA times CP equals to DO times OB. DO equals to 10 over 3. BO equals to 20 over 3. So in total we got that 2 over 3 times root 13 equals to OP, and OP equals to OC plus CP. This is actually OP, OC plus CP, equals to DO, that is to say 10 over 3, times OB, that is to say 20 over 3. Okay, it is 10 over 3 times 20 over 3. Okay, now I will write the value of OC. OC equals to 4 over 3 times root 13, so I write it down. OC equals to 4 over 3 times root 13 plus CP. CP is the line segment that is that we want to find out the value of it, so it will remain as it is, plus CP. Only CP is missing in this equality, so it is one equation in one missing variable, and we can find it easily. You can find it easily. So here OC equals to 4 over 3 times root 13 plus CP, and OD is 10 over 3 and BO is 20 over 3. 10 times 20 is 200. First of all, okay, 10 times 20 is 200, so I'll write it down. So 10 times 20 is 200. We have in the denominator 3 times 3, but we actually have 3 in the denominator of this side of the equation, and we have 3 in this side in the denominator of this side of the equation, so we can cancel 3 because we have 3 in those in both those two sides of the equation. Okay, so in total we will get that root 13 times root 13 is 13 here. So we have here 2 times 4 is 8, and root 13 times root 13 is 13. So in total we got 8 over 3 times 13 plus 2 times root 13 times CP. 2 times root 13 times root 13 all equals to 200 over 3. And 3 times 13 is 104. So I write it down. Okay, 8 times 13 is 104. In total we have here 104 over 3. So we will subtract 104 over 3 from this equality. So in total we got that 2 times root 13 times CP equals to 200 minus 100 over 3. And 200 minus 104 is 96, so I write it down. Again, 200 minus 104 is 96. In total we have in this side of the equation 96 over 3. And in this side of the equation we have 2 times root 13 times CP. 96 over 3 is 32, so I write it down. Okay, in total we got that 2 times root 13 times CP equals to 32. I will divide this equality by 2. So we divided this equality by 2. We got that root 13 times CP equals to 16. We divide this equality by root 13. So we divided this quality by root 13. We got that CP equals to 16 over root 13 units. Okay, so we found out that the value of line segment CP equals to 16 over root 13 units. Okay, the value of line segment CP equals to 16 over root 13 units. In the next step, we will extend line segment DC until it reaches at the circle, until it touches the circle at point Q. We will extend line segment DC until it touches the circle at point Q. So we created new line segment CQ, and we will find out the value of CQ. We'll calculate the value of CQ according to the fourth rule. Actually, we have chord DQ intersects with chord AP at point C. So C is the point of intersection between chord DQ and chord AP. Therefore, according to rule number 4, the following equality is true whenever two chords are intersecting each other. Then we can use the fourth rule. Okay, we have here two chords. Chord DQ intersects with chord AP at point C. So we have the following rule, according to rule number 4, that is true in this circle. DC times CQ equals to AC times CP. Okay, DC times CQ equals to AC times CP. I will explain again. Chord DQ intersects with chord AP at point C. Point C is the point of intersection between chord DQ and chord AP. Therefore, according to rule number 4, DC times CQ equals to AC times CP. Okay, but we know that DC equals to 6. CQ is the line segment that is missing, that we want to find out the value of CQ. So I will leave CQ as it is, equals to AC. AC equals to 2 over 3 times root 13 plus 4 over 3 times root 13. In total, okay, I write it as it is. 2 over 3 times root 13 plus 4 over 3 times root 13. That is the value of AC times CP. We have already found out that the value of CP, line segment CP, is 16 over 13 over 16 over root 13 units. So we can write here that CP equals to 16 over root 13 units. Okay, so in total we got that DC is 6, so it's 6 CQ. CQ is the line segment that we want to find out the value of it, so we will leave it as it is. AC equals to 2 over 3 times root 13 plus 4 over 3 times root 13. And we have already found out that the value of CP equals to 16 over root 13 units. Okay? Okay, so we will do here the arithmetic. 2 plus 4 is 6, so in total we will get 6 CQ equals to 6 over 3 root 13 times 16 over root 13. Okay, 2 plus 4 is 6, so in total we got here 6 over 3 times root 13 times 16 over root 13. So we have here root 13 in the numerator, and we have root 13 in the denominator. So root 13 can be cancelled. Okay. So in total we will get that here 6 over 3 is 2. In total we got here 2 times 16, and here we have 6 times CQ. 2 times 16 is 32. I will write it down. So we got that 6 times CQ equals to 32. We will divide this equality by 6. So we got that CQ equals to 32 over 6. 32 we divide it by 2, it is 16 over 3. So we can write here that CQ equals to 16 over 3 units. Okay? In the next step, we will extend line segment BC until it touches the circle at point R. Again, we extend that line segment BC until it touches the circle at point R. Okay, so we actually created new line segment RC, and we will find the value of line segment RC according to rule number 4. We actually have two chords that are intersecting each other at point C. Chord DQ intersects with chord RB at point C. I will write it down. Chord DQ intersects with chord RB at point C. Therefore, according to rule number 4, DC times CQ equals to BC times RC. Again, chord DQ intersects with chord BR at point C. C is the point of intersection between those two chords. Therefore, according to rule number 4, DC times CQ equals to BC times RC. I will read again what I wrote. Chord DC intersects with chord RB. Chord DQ intersects with chord RB. Chord DQ intersects with chord RB at point C. Okay, chord DQ intersects with chord RB at point C. Therefore, according to rule number 4, DC times CO equals to BC times RC. Actually, it is DC times CQ. Okay, it is DC times CQ equals to BC times RC. Okay, the equality is according to rule number 4, DC times CQ equals to BC times RC. Okay, but we know that DC equals to 6 units, CQ equals to 16 over 3 units, BC equals to 8 units, RC is the missing line segment. Okay, so in total we got that DC is 6, so we have 6 times CQ is 16 over 3 equals to BC is 8 times RC. Now 6 over 3 is 2, so I write it down. Okay, 6 over 3 is 2, so in total we have in this side of the equation 2 times 16 equals to 8 times RC. 16 times 2 is 32. and 32 over 8 is 4. Okay, 2 times 16 is 32, and here we have 8 times RC. We will divide this equality by 8. So 32 over 8 is 4, so we got that RC equals to 4 units. So we can write here that RC equals to 4 units. So we actually know the values of all the line segments in this circle, and the only thing that is missing is the radius of this circle, and after we will find the radius of this circle, we will know immediately the area of this circle, because the formula for the area of any circle equals to pi times the radius squared. Okay, so in order to find out the radius of this circle, we have rule number 5. Rule number 5 states that if two chords are intersecting each other at 90 degrees, we have two chords we have chord A, B that intersects with chord C, D at point O. Point O is the point of intersection, and they intersect each other at 90 degrees. That is to say, this angle is 90 degrees. Then in this situation, the following equality is true: that 4 times r squared, r is the radius of this circle, equals to AO squared plus BO squared plus CO squared plus DO squared. Okay, again, rule number 5 states that if two chords, let's say AB, chord AB and chord CD, are intersecting each other at point O, and they create with each other 90 degrees, this angle is 90 degrees, then the following equation or equality is true: that 4 times r squared, when r is the radius of this circle, equals to AO squared plus BO squared plus CO squared plus DO squared. Okay, so I will write down rule number 5. Rule number 5 states that if two chords are intersecting with each other each other at 90 degrees, at point O. Point O is the point of intersection between chord AB and chord CD. Then the following equality is true. For r square, when r is the radius of this circle, equals to AO square. So in the point of intersection, point O, we created 4 line segments. And line segment AO square plus line segment BO square plus line segment CO square plus line segment DO square equals the sum of these 4 line segments squared equals to 4 times the radius squared. So I will read again rule number 5. Rule number 5 states that if 2 chords are intersecting each other at 90 degrees at point O, then the following quality is true. That 4 times r squared, when r is the radius of the circle, equals to AO square plus BO square plus CO square plus DO square. O is the point of intersection between those 2 chords, chord AB and chord CD. Okay, so we actually can implement rule number 5 in our circle in order to find out the value of the radius of this circle. Angle BCD equals to 90 degrees. So actually we can say that chord RB intersects with chord DQ at 90 degrees, because this angle is 90 degrees. All the angles here are 90 degrees. So we can say that chord DQ, this chord intersects with chord RB at 90 degrees. And the point of intersection is at point C. Therefore, according to rule number 5, DC 4r squared equals to DC squared plus CQ squared plus BC squared plus RC squared. So I will read again what I wrote. Angle BCD equals to 90 degrees. Angle BCD equals to 90 degrees. This angle equals to 90 degrees. It is given us in the question. And actually chord DQ intersects with chord RB. Chord DQ intersects with chord RB at 90 degrees. This angle is 90 degrees and the point of intersection is point C. Therefore, according to rule number 5, 4r squared when r is the radius of this circle equals to DC squared plus CQ squared plus RB squared plus RC squared. So whenever two chords are intersecting with each other at 90 degrees, we can implement rule number 5. And in this circle we have two chords, chord DQ and chord RB, that are intersecting with each other at 90 degrees. Therefore, we can implement rule number 5 in this circle. Okay, so 4 times r squared equals to DC squared. DC is 6, so DC squared is 36 plus CQ squared. CQ is 16 over 3. 16 over 3 is 5 and third. So we have 5 third squared plus BC squared. BC is 8, so BC squared is 64. Plus RC squared. RC is 4, so RC squared is 16. So in total we got that 4 times r squared when r is the radius of the circle equals to 36 plus 5 third square plus 64 plus 16. 64 plus 36 is 100 and 100 plus 16 is 116. So I will write it down. So in total we got that 4r squared equals to 116 plus 5 third squared. 5 third squared is 28.444, so I write it down. So we got that 116 plus 28.444 equals to 4 times the radius square. 116 plus 28.444 equals to 144.444, so I write it down. So we got that 4 times the radius square equals to 144.444, and we will divide this equation by 4, so we will get that r square equals to 36.111. Okay, so we got that the radius squared equals to 36.111. Now we know that the area of any circle in the world equals to pi times the radius. Okay, the area of a circle equals to pi times the radius squared. Okay, that is the formula for the area of any circle. It is pi times the radius squared. So the area of this circle will be pi times 36 times 1 square units. So the area of this circle will be equal to pi times r square, and pi times r square is actually pi times 36.111 square units. Or in terms of numbers, we'll get that the area of the circle equals to 113.47 units, square units. Okay, so the area of the circle equals to 113.47 square units. Okay, so now I will summarize the lecture. .45, okay. If we want to be more accurate, the area of the circle equals to 113.45 square units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the radius of this circle, and inside the circle we have a shape, and we have the values of two angles in this shape. Angle ADC is 90 degrees, and also angle BCD is 90 degrees. And we know that side AD equals to 4 units, side DC of the shape equals to 6 units, and side BC of the shape inside the circle equals to 8 units, and we want to find out the area of this circle. Okay, first of all, I will explain. I explained you the theorem of one-sided angles, and we also have rule number 1 of one-sided angles. Okay. Actually, one-sided angles here we have alpha and beta are one-sided angles, are interior one-sided angles. Why they are one-sided angles? Because both of them located in one side of this right line C. Okay, they both located on this side of line C. Okay, so they are defined as interior one-sided angles. And the other possibility that we have is those angles alpha and beta are exterior one-sided angles, and we actually have rule number 1 that states that if the sum of angles alpha and beta equals to 180 degrees, then line A is parallel to line B. So if alpha plus beta equals to 180 degrees, then line A is parallel to line B. And also here, if the sum of internal one-sided angles alpha and beta is equal to 180 degrees, then line A is parallel to line B. Okay, so we actually can implement rule number 1 in our circle, because in our circle we have two line segments, line segment AD and line segment BC, and we have two one-sided angles. Angle ADC is a one-sided angles, and angle BCD is also one-sided angles. And the sum of those two one-sided internal angles, angle ADC plus angle BCD, equals to 180 degrees. Okay, therefore, according to rule number 1, line segment AD is parallel to line segment BC. Okay, so we know that those two line segments AD and BC are parallel to each other according to rule number 1, because of the fact that the sum of the one-sided angles, angle ADC plus angle BCD, equals to 180 degrees. So AD is parallel to BC. Okay, now we focused on the two green triangles, triangle AOD and triangle BOC. Actually, angle AOD equals to angle BOC. Those two angles are equal to each other because those are vertex angles, and vertex angles are equal to each other. Actually, when two lines, line AB and line A and line B, are intersecting each other, they create four angles: angle 1, 2, 3, and 4. Actually, angle 1 and angle 3 are defined as vertex angles, and according to rule number 2, vertex angles are equal to each other, and also angle 2 and angle 4 are vertex angles, and according to rule number 2, they are equal to each other. Okay, so actually we have two types of vertex angles. Here, alpha and beta are vertex angles, and according to rule number 2, they are equal to each other. And also, we have the other type of vertex angles. Here, also alpha and beta are vertex angles, and according to rule number 2, they are equal to each other. And I will read rule number 2. Rule number 2 states that vertex angles are equal to each other. Okay, vertex angles are equal to each other. Alpha and beta are vertex angles, and therefore they are equal to each other. And here also alpha and beta are vertex angles, therefore they are equal to each other according to rule number 2. Okay. So we know that angle COV equals to angle DOC. Those two angles are equal to each other. And also angle AOD, angle BCO are equal to angle DAO. Those two angles are equal to each other because they are alternating angles, and alternating angles between parallel lines are equal to each other. AD is parallel to BC according to rule number 1, therefore those two alternating angles are equal to each other. And also angle ADO equals to angle CBO. Those two angles are equal to each other according to the rule that alternating angles are between parallel lines are equal to each other. AD is parallel to BC, so and angle ADO and angle CBO are alternating angles, and alternating angles between parallel lines are equal to each other. So that is actually rule number 4. Rule number 3 that states that alternating angles between parallel lines are equal to each other. Okay, so actually the alternating, those alpha and beta are alternating angles, so if A is parallel to B, then angle alpha equals to angle beta according to rule number 3. And those two angles, alpha and beta, are exterior alternating angles, and if line A is parallel to line B, then those two angles, internal, external, exterior alternating angles, are equal to each other. Okay, those are interior alternating angles, and if A is parallel to B, they are equal to each other, and those two angles are exterior alternating angles, and if line A is parallel to line B, then those two angles are equal to each other. So we actually proved that this angle equals to this angle. Those two angles are equal to each other, and those two angles are also equal to each other. So we actually proved that three angles of these green triangles are equal to three angles in this green triangle. So according to angle, we actually proved that the big green triangle is similar to the small green triangle. And actually, if we have two similar triangles, if the big triangle ABC is similar to the small triangle EDF, that is to say, three angles in this big triangle are equal to three angles in the small triangle, then the following relationship between the sides of those two triangles are true. AB over DE equals to BC over EF equals to AC over DF. Okay, so we actually implemented this rule in our circle. We can say that OB over, we know that those two green triangles are similar to each other because we proved that three angles in this green triangle equals to three angles in this green triangle. So therefore those two green triangles are similar to each other. Therefore the following relationship is true. That is to say, BO over OD equals to OC over AO, that equals to BC over AD. Okay? BO over AD equals to OC over OA equals to BC over AD, but we know that BC equals to 8 units and AD equals to 4 units, so 4 over 8 is 2. So we have those two equalities, that OB equals to 2 times OD and OC equals to 2 times AO. So we actually, if this is B, if AO is B, then OC is 2 times AO, so OC is 2B, and if OD equals to A, then BO equals 2 times A. Okay? According to the equality that OB equals to 2 times OD and OC equals to 2 times AO. Okay? And we actually know that angle ADC is a right angle, it equals to 90 degrees, so we can, so triangle ADC is a right angle because angle ADC is a right angle, so we can implement the Pythagorean theorem in order to find out we can implement the Pythagorean theorem in order to find out the value of A. And actually AC square equals to the square of the hypotenuse equals to the sum of the squares of the perpendiculars equals to DC square plus AD square. Okay? AC square equals to AD square plus DC square. Okay? And the only missing variable here is B. The only missing variable is B, because we know that this equals to 6 and AD equals to 4, so we can easily solve this equation, and we found out that B equals to 2 over 3 times root 13, while 2B equals to 4 over 3 times root 13. Okay, so we found out the values of line segment OC and line segment OA. In the next step, we know that angle BCD equals to 90 degrees, so triangle BCD is a right triangle, so we can implement the Pythagorean theorem in this right triangle. That is to say, BD squared, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars, equals to DC squared plus BC squared. Okay? The B squared equals to DC squared plus BC squared. And we know that DC equals to 6, BC equals to 8, and the only missing variable here is A. DB equals to A plus 2A, TB equals to 3A. So we have only one variable missing with one equation, so we can easily find out that A equals to 10 over 3, while 2 times A equals to 20 over 3. So we found out the values of all the line segments in this circle, and in the next step we actually extended line segment AC until it touches the circle at point P. So we actually extended line segment AC until it touches the circle at point P, and we have actually rule number 4 that states that if two chords, chord AB and chord CD, are intersecting each other, let's say at point O, the point of intersection is point O, then the following equality is true, that AO times BO equals to CO times DO. Again, if we have two chords, chord AB and chord CD, that are intersecting each other at point O, then we have the following equality that is true, that AO times BO equals to CO times DO. Okay, AO times BO equals to CO times DO. That is actually rule number 4. Again, if two chords AB and CD are intersecting each other at point O, the point of intersection is point O, then the following equality is true. AO times OB equals to CO times OD. Okay, so we can implement rule number 4 in our circle, because we have chord AP that intersects chord DB. Those two chords are intersecting each other at point O. Therefore, according to rule number 4, AO times OP equals to DO times OB. Okay? AO times OB equals to DO times OB. AO times OP equals to DO times OB, according to rule number 4. And we actually know all the values of all the line segments here, and the only missing variable, or the only line segment that is not known is CP, and we put the data inside this equality, and we found out that CP, line segment CP equals to 16 over 13 units. Okay, so then in the next step we extend that line segment DC until it touches the circle at point Q. Okay, and then we implemented rule number 4 in order to find out the value of CQ. Actually, we have chord DQ that intersects with chord AP. Chord DQ intersects with chord AP. Chord DQ intersects with chord AP at point C. So according to rule number 4, DC times CQ equals to AC times CP. Again, chord DQ intersects with chord AP at point C. So according to rule number 4, DC times CQ equals to AC times CP. According to rule number 4, DC times CQ equals to AC times CP, and again we know all the values of the line segments here. The only missing line segment is CQ. So we put all the data in this equality, and we found out that CQ equals to 16 over 3. Okay, CQ equals to 16 over 3 units. And in the next step, we extended line segment BC until it touches the circle at point R. Again, we extended line segment DC until it touches the circle at point R, and then we calculated the value of RC. The new segment that was created is RC, and we calculated the value of RC according to rule number 4. Actually, we have line segment DQ. Line segment DQ intersects with line segment RB at point C. So according to rule number 4, DC times CQ equals to BC times RC. Okay, again, DC times CQ equals to BC times RC. Okay, DC times CQ equals to BC times RC. Okay, again we have all the values of the line segments here. The only missing line segment is line segment RC. So we put all the data in this equality, and we found out that RC equals to 4 units. Okay, so right now we know all the values of all the line segments inside the circle, and the only missing thing is the radius of this circle, and we found out the radius of this circle according to rule number 5. Rule number 5 states that if two chords are intersecting each other at 90 degrees at point O, then the following equality is true. 4 times R squared equals to AO squared plus BO squared plus CO squared plus DO squared. Again, if we have two chords, chord AB and chord CD, that are intersecting at point O at 90 degrees, angle AOD is 90 degrees. So at the point of intersection, point O, they create 90 degrees with each other, then the following equality is true. 4 times r squared when r is the radius of this circle equals to a all squared plus b all squared plus c all squared plus d all squared. So we actually can implement rule number 5 in our circle because we have angle BCD that equals to 90 degrees. So actually chord RB creates with chord DQ 90 degrees. So in the intersection point, that is to say in point C, we have 90 degrees. So chord RB intersects with chord DQ at 90 degrees. So we can implement rule number 5 here in this circle. According to rule number 5, 4 times r squared equals to dc squared plus cq squared plus bc squared plus rc squared. Okay, so according to rule number 5, dc squared plus cc squared equals to bc squared plus rc squared. Because of the fact that chord DQ intersects with chord RB at point C at 90 degrees, then the following rule is true. Okay, so we actually have all the values of all the line segments, so we can put the data inside this equation. The only missing variable is 4r squared. So we put the data in this equality and we found out that r squared equals to 36.111. R squared equals to 36.111 units, and the area of any circle equals to pi times the radius squared, the radius of the circle squared. So we know that r squared equals to 36.111. So the area of this circle will be equal to pi times 36.11 square units or the area of this circle equals to 113.45 square units. Okay, the area of this circle equals to 113.45 square units. Okay, thank you very much.